Let's look at our first example of a proof with triangles. I have the figure drawn here, so draw this in your notes and label it carefully. We are given that C is the midpoint of segment BF and AC is congruent to CE. Segment AC is congruent to segment CE. And we need to prove triangle ABC is congruent to triangle EFC. That is our goal. So let's go ahead and use what was given and label the figure. So if C is the midpoint of segment BF, that means C is the midpoint. So that divides it perfectly in half, and that means that BC would be congruent to CF by definition of midpoint. And then AC is congruent to CE was given. So if AC is congruent to CE, and that was given, we have those two sides. So then we look at our figure and see what else do we know about this figure. So we are always able to say that vertical angles are congruent. So angle BCA would be congruent to angle FCE because they are simply vertical angles, which is where two lines intersect, the angles opposite are congruent. So now we have enough information to state that these triangles are congruent. We can tell that we have a side, angle, side, and a corresponding side, angle, and side in the other triangle. So by side, angle, side, we're going to state that these are congruent. So let's write out our formal proof with a two-column setup. So number one is going to be our given. So C is the midpoint of segment BF, and that was given. So just like we labeled the figure, what did that tell us? That told us that BC is congruent to CF. So let's state that second. Let's say segment BC is congruent to segment CF, and the reason is we would say definition of midpoint. All right, so the third thing we noticed about our figure was given AC is congruent to CE, we labeled those two sides. But since we're going to do side, angle, side for our final statement, so we're going to state at the very bottom, triangle ABC is congruent to triangle EFC. And we know that we're going to say side, angle, side. I just want to point out that it's nice in your proof if you actually list things in that order. It just flows really nice and organized. So we've listed a side. So for the next part, I want to list the angle. So let's put number 3 will be the angles we found were congruent because they're vertical angles. So I'm going to put angle ACB would be congruent to angle FCE. And like I just said, that's because those are vertical angles. And then I'm going to list the side that was given because it just flows well to have our side, our angle, and then our side, and then we state that these are congruent by side, angle, side. It makes lots of logical order and sense. So I'm going to put that side AC was congruent to side CE, and that was right here. That was given. So that's the only reason we need for that one. And then we know this is step number 5 is our proof. And by the way, you can always write that part at the very bottom. It's just you never know how much room you need, but that'll always be the last step is what you're going to prove. And then if you already know why, you can list that, and it'll help guide your proof with the right order of things. Like I said, side, angle, side, side, angle, side. It looks really nice and organized. So let's look at the other 2 ways we could have written this. I have the flow proof set up already for you. So I have C as the midpoint of side BF. That told me that BC was congruent to CF by definition of midpoint. So I drew an arrow because that given statement gave me this piece of information. Then in the middle here I wrote that angle ACB would be congruent to angle ECF because they are vertical angles. And then on this side I put that AC is congruent to CE again because that's just given. And then these 3 things are still in the right order like I just talked about. That's a side, angle, and a side. So therefore I can conclude that these triangles are congruent because of side, angle, side. But it's really nice and neat to have it in that order as you stated at the final conclusion. So then the last method is the paragraph proof. Again, we've talked about how this is the least formal method, but it is another method we could use. So it is given that C is the midpoint of segment BF, and AC is congruent to CE, and angle ACB is congruent to angle ECF because vertical angles are congruent. By definition of midpoint, BC is congruent to CF, and we can conclude that triangle ABC is congruent to triangle EFC by side, angle, side. So those are our three methods for proving that these two triangles were congruent.